All right, this is one of the t-tests. You got to know which kind of t-test. And because the word claim is in there, that means it's a one sample t-test. In fact, we only got one sample, right? Boom, that's the sample. The Department of Commerce from the U.S. is claiming, there's that word claim again, that 7% is the unemployment state average. So these are all the states, all 50 states that your sample size is in. So the first thing, we're going to just follow this formula. That's the fastest way. And we're going to go to, right, we need the mean. And the mu is the claim. That's what they say is 7%. S is the standard deviation from this sample. And the square root of n. So let's just find out what the mean is. Go to the function bar. Go to statistical. And there's average right there. Click. And it says, where do you want the average taken from? And you highlight the data. Right there. Boom. Enter. So the mean is 6.8. Let's make it to two place values. Thank you very much. Boom. Standard deviation. Same thing. You click the cell. Go to the function bar. Make sure you're in statistical. And then scroll down to standard deviation. And we always use the one that ends in an S. Right? Like there's a Saint Dev A, Saint Dev S, Saint Dev P. We always use the one with an S. I'm sorry. That means sample. And we're always dealing with samples. So standard deviation sample. Click OK. Same thing. It says, where do you want the numbers from? You highlight the data. Just the data. So we got the standard deviation. We got the mean. We're going to go ahead and put them up here. So our mean is 6.83. Our standard deviation is 2.71. Our sample size, that's what the little n is. Sample size, we got 50. So now we're just going to plug them into this formula. So our t-test statistic is, all right, so it's going to be the mean of 6.81. What happened to my other zero there? 6.83 minus the stated of 7.00, right? So let's just put that in there. We're going to put 6.83 minus 7.00. That's our top number, right? And let's go ahead and do that right now. That looks like a negative 0.17. Is that about right? That's about right. Right? So again, that's the numerator of this. And I only want 2 decimal places. Thank you. And then the denominator is going to be our standard deviation, which is, we'll just put that in there this way. I'll put equals. Our standard deviation is that cell. And I'm going to divide it by the square root of 50 is roughly 7.1. So I'm just going to use 7.1 as the square root of 50. And we're going to get that number. So that's our numerator. Okay? There's our top number. Difference between the sample mean and 7%. Our bottom number is the standard deviation of 2.71 divided by the square root of 50, which is, here, I'll just show you this real quick, equals, I want that cell shift 6, that's the caret, to be exponent raised by 0.5, which is the same as the square root. And you're right, that comes out to be about the same as 0.71. Let's get that so you can see it. Again, I only want 2 place values. So that's close enough for me. So now I'm going to divide these two. Well, actually, let's get the right number. So by 70707. I don't want to work. Okay, so it comes out to be the same. And now we divide them. I pick this empty cell. I hit the equal sign, and I say I want the top number divided by the bottom number. And that gives me the t-test statistic. So that is this number right here is the t-test statistic, right? This is t. This is your t-score. And hopefully you remember that it's got to be bigger than 2 and before it's significant or pretty close to it, depending on everything else. So that's our t-value. Now, we should look that up in a table. And let's do that real quick. I have a table on our website somewhere around here. There it is right there. Boom. So we have a t-value of negative 0.44. And our degrees of freedom is the total sample size minus the number of groups or number of samples. So we got 50 total in, minus 1 is 49, and it doesn't go past 29, so we're simply going to use this infinite sign. So anything past 30, in reality, it's the same number. So we're going to look for 30 at 0.05%. Where is that? And we're just calling this a two-tailed test. So two-tailed is at 0.05. You see that? Two-tailed, 0.05. We're going to scroll down here, and we don't see the number of 0.044. So what it really is it would be, if we followed it this way, it would be way over here somewhere, right? See how the numbers are getting smaller? 1.96, 1.645, 1.25. So our negative 0.44, don't forget about the negative thing, right? The t-test, we just take the absolute value. So 0.044, or I already forget what it was. Hold on a second. 0.44 would be it'd be right around here somewhere. So on a two-tailed test, your sig value is going to be plenty high. It's going to be like 0.6 or something. So what that means is there is no significant difference in there. But now I'm going to show you another way to find the p-value. Let's find the p-value. So what we do is we use Excel again, and we simply go to the function bar, and we want a t-test. There's a lot of different ways to do this. Hold on, that was wrong. I'll go in here and go t distribution. Is that what we want? Returns the left tail. That's a less than. And that's the one we want, 2. So we're going to double click on this. And it wants that formula. This is what's your t-score? Our t-score is 0.44. Degrees of freedom, remember, it's the total sample size of 50 minus the number of groups, number of samples, and we got 1. So it's 49. And we're going to get an exact p-value. That's our exact p-value. And because it's not less than 0.05, we cannot reject the null. So the answer to this question is that we cannot reject the null, so therefore the government's claim of 7% is true. We have to accept it as true because our data, our sample size, did not say otherwise. So that's how the first one's done. Okay.